This is Daryl with Cisco Hands-On Training. Today we're going to continue our discussion of VLANs and spanning tree with a spanning tree 2 episode. It's the 21st of February 2009. The website is www.ciscohandsontraining.com. The diagram for tonight's episode will be on the website in the comments for the blog entry / episode. In iTunes, you can always find Cisco Hands-On Training by searching on Cisco Podcast. And I'm pleased to announce that Cisco Hands-On Training is the most popular Cisco podcast in iTunes. If you enable the popularity window and then sort on popularity, you can see we're right there at the top. So that's great, and I thank you all for your support. You can continue to support me by linking to my website. And I also want to thank Robert Walter for loaning me a 2621 and a 2524. As you know, one of my routers died. The 2621 is going to be very helpful, particularly because the 2621 has two 100 meg interfaces. And those 100 megabit interfaces, you can run 802.1q trunks on them with sub interfaces. And we're right about to get to the 802.1q trunk episode. It's like one episode or 2 episodes away at this point. So that's going to be very helpful for us. But today we're talking about spanning tree. We're going to talk about spanning tree priority, portfast, bpduguard, rootguard, bpdu filter, and I'm going to try to do examples of uplink fast and backbone fast, although I was having some trouble with backbone fast during prep, so we'll see how well that goes. Let's start by talking about the spanning tree priority. As you know from the last episode, the first thing that spanning tree does is when each switch comes up, each switch assumes that it is the root bridge and it starts sending out BPDUs. Included in the BPDUs is its spanning tree priority, which by default is in the 32,000 range, like 32,768 or something, and the bridge's MAC address. And the lowest priority wins. And if the priorities are the same, then the lowest MAC address wins. So here's a network diagram. And my question to you is which switch / bridge in this topology is the root bridge? And of course you can't answer that right now because you don't know what we've configured with the spanning tree priority. Okay, let me say I have not configured a spanning tree priority. Well, you still don't know. The answer is if you haven't configured a spanning tree priority and they're all at the default and the default happens to be the same on this particular model switch, then it will end up being the switch with the lowest MAC address. And that could be very, very bad. In fact, one of my first horrific outages after becoming a network team lead back in '99 was where we built a network like this at one of my previous employers, and we had distribution with 2 new Cat 6Ks. 1999 was the year that the Cat 6K came out, and then we had our old Cat 5Ks out in different buildings. So our intention was this would be the core / distribution of our network, and then we'd have access switches hanging off of it. So we had a bunch of Cat 5Ks, and then we had some older switches out there. Well, guess what? The switch, which happened to have we didn't configure spanning tree because at the time I didn't really understand the spanning tree priorities. I didn't understand spanning tree well at the time. We didn't configure spanning tree priority, and this switch down here, which was an old 2924 with 100 meg interfaces, became our spanning tree route because it had the lowest MAC address. So I have this nice core up here, nice new Cat 6Ks, cost a lot of money, and this is the center of my network down here. And my network was built, and it all looked like it was working fine. And then one day the bandwidth going through the core of the network exceeded 100 megabits, and suddenly we suffered horrific packet loss, and we had a horrible network outage, and so we figured out what was going on. So the lesson to you is that it is important to decide what your root bridge and backup root bridge are for your network topology, and generally you want most networks have a core, and then they have a distribution layer, and then they have access switches, an access layer. And typically your distribution layer is a combination layer 2 and layer 3, meaning it has routed uplinks and switched downlinks. And generally you want your two devices in the distribution layer to be the spanning tree root, one of them to be the spanning tree root, and the other one to be the spanning tree backup root for each VLAN. And so if this is the spanning tree root, then all of these ports here will be designated ports and be forwarding. These ports which face towards the spanning tree root will be designated root ports, and they'll be forwarding. And then these links over here will be blocking, either down here or up here. Okay, so setting spanning tree is important, and since it's important, let's go ahead and do it. In fact, here I am on switch number 1, show spanning tree. I only have one VLAN at this point, and so for spanning tree number 1, the root ID has priority 32769, and the cost is 19, which is the cost of a fast Ethernet link with this revision of spanning tree, and it's out fast Ethernet 0/2. So so the root bridge is somewhere out this way. Well, I know from the topology I only have 1, 2, 3 switches. I know that means the root bridge is switch 2 in this case, because these are all fast Ethernet. In addition, I also know that because the cost of a fast Ethernet link is 19, and the cost, and my link out fast Ethernet 0/2 is fast Ethernet, so I'm exactly one hop away from the spanning tree root. So in the show spanning tree output, I have my own priority, which is the default. I'm sorry, down here I have my own priority. Up here I have the root bridge priority. You can see the priority is the same, but the root bridge MAC address is different. And you can see that the root bridge that is out past Ethernet 0/2 has a MAC address starting with 0017, and my MAC address is 001A. And 0017 is less than 001A. Again, this is hexadecimal, so the A is the equivalent of 10 in decimal. So that makes sense that that the switch out this way would win the election between these two switches. Okay, so what I've just explained is we have a problem. Our spanning tree root is not well configured, and frankly, if I plug in another switch and that switch happens to have a lower MAC address, it could become the root and I would have spanning tree reconversions. So I just do a regular operation. I just plug in an additional switch, or maybe somebody plugs in a hub at their desk, or somebody plugs in a switch at their desk that they bought from Costco or Fry's or whatever, and suddenly you got a 30 to 50 second network outage. Well, that's bad. So what do you do about it? Well, the first thing you do is you set your spanning tree roots. So conf t spanning tree VLAN 1, and I could set the priority to a number, or I could use what's called a macro and set it as root. So let me set spanning tree VLAN 1 root. And then I hit question mark, and I have a choice of a primary or a secondary. Now in my network designs, I always make the one on the left be the primary root, and the one on the right be the backup root. So I'm going to set the spanning tree VLAN 1 root, primary, and I did that, ping 10.1.1.3, and I can ping it. Ping 10.1.1.4, I cannot ping it. And I should be able to ping it right now, except I'm doing a spanning tree recalculation right now. In fact, let's go ahead and enable some spanning tree logs here. Conf t int range fast 0/1 to 24 logging event spanning tree. And as long as I'm here, logging event link dash status and logging event status. And now I can ping 10.1.4. So you can just see that when I set the spanning tree root, I lost pingability down here to switch 3. And the reason is that switch 2 used to be the root bridge. I became the new root bridge. I started sending out, switch 1 became the root bridge. It started sending out BPDUs, and they were superior BPDUs, and I could ping switch 2 very fast. Basically, switch 2 decided that he believed me for really quick, but switch 3 had to think about it for a while, and it went through the probably went through the listening and learning stages to make sure that there wasn't to make sure that it just wanted to be safe. It didn't want to enable its new port up here for a while to avoid a loop, to avoid looping traffic, which would cause a 100% CPU outage as we saw last time. So spanning tree recalculations take time. By configuring a new root bridge, I caused an outage for approximately 30 to 50 seconds to switch 3, and so spanning tree has some serious issues, and you want to be careful about adding and deleting switches from your environment in production. Okay. Show log. So I enabled that logging. Okay, it's about 1 hour since I booted. I do not have a clock accurately set on this box, so it's counting the amount of time since I booted. These are old messages back here from back when I was setting up earlier. So here I've configured, and I don't have any useful log messages since I configured the spanning tree. Let's look at the show spanning tree. And VLAN 1. And you can see my root bridge my priority is 24577 now. So when I configured spanning tree VLAN 1 root primary, it decreased my priority. And it says this bridge is the root. So you can see down here it shows, in this section it always shows me my MAC address. And up here it shows the MAC address of the root bridge, and then you notice the MAC addresses are the same. Well, the reason the MAC addresses are the same is because I am the root, and I'm the root because I have the lowest priority. I have a lower priority because I configured spanning tree VLAN 1 root primary. And you notice I'm forwarding out all ports. My 10 megabit port to the router has a cost of 100 in terms of spanning tree, and then my other 2 ports, which are fast Ethernet, have a cost of 19. Okay, let's finish the other part of this reconfiguration, which is on switch 2. Okay, I moved my console to switch 2 in my high-tech lab here. Show spanning tree. And notice I did not specify a VLAN, so it shows me VLAN 1. And my priority is 32769. And what that actually is, it's actually 32768 for the switch, plus it adds 1 for every VLAN. And since this is VLAN 1, it added 1, and so the default priority on this switch is 32769. Here is my spanning tree, my MAC address on my switch, and here is the MAC address of the root bridge, which is out fast Ethernet 0/1 and has a cost of 19. And that makes sense. I'm on switch 2, fast Ethernet 0/1 goes over to switch 1. Okay, I want to set switch 2 to be the backup root. Conf t spanning tree VLAN 1 priority root secondary. Okay. Show spanning. Now this should not cause impact because I'm not actually changing the root bridge here. It's just if the root bridge stops sending out BPDUs, then once I figure that out, which is the maxage timer, which by default is 20 seconds, once I figure that out, then this switch will try to become the root bridge. Show spanning tree VLAN 1. And you can see that the root bridge, switch 1, which is configured spanning tree VLAN 1 root primary, has a priority of 24577, and I have a priority of 28673, and then out, and then switch 3 still has the default priority, which is 32769. So in the event switch 1 goes down, switch 2 will become the will assume the spanning tree root bridge rule until switch 1 comes back online, which is exactly what we want. Okay, so that is spanning tree priority. Oh, one more thing. Let's go look at that config. Show run pipe include spanning tree. Take a look at this. Spanning tree VLAN 1 root secondary is not in the config. That is actually a macro. When you type that in, the iOS will put in a priority command for you. So spanning tree VLAN 1 root secondary or spanning tree VLAN 1 root primary, those are macros which actually get translated into priority commands. And they will adjust the priority. I believe that if they will adjust the priority down, so if you say that you want to become the spanning tree root, it'll actually look at the spanning tree priorities out on your net and pick a priority even lower than any existing priority than the existing root bridge. Okay, so that is spanning tree priority, and it is important to decide which switches are appropriate to be your spanning tree root and backup root and set them. Okay, the next thing we want to do, let's look at 10.1.1.1, and let's actually pause for a second. Ping 10.1.1.1. I'm back on router 1 here, and it's pingable. And then let me pull the cable and see what happens. So I've pulled the cable, and the box is not pingable. And now let me plug it back in. And it's plugged back in, but my pings are still failing. Dot, dot, dot. The line protocol is up, but the pings are still failing. And here I am just waiting around, and here you can see the logging. It moved to the line protocol came up, spanning tree started out in listening mode, it went to learning mode, and we're still waiting, and we're still waiting, and the box is still down, and now I can ping it once it moved from learning to forwarding. Okay, so that's spanning tree. It goes from listening to learning to forwarding. It can take, going from listening to learning takes 15 seconds. Going from learning to forwarding takes 15 seconds. So we took a 30-second hit just by flapping this link for a couple seconds. Well, that's bad. Spanning tree is designed to prevent loops in your topology, but you know, I don't have any loops here. This is just an access port going to a router, or it could be an access port going to a host. And you're telling me that when you plug in, it takes 30 seconds before you have network connectivity? Well, that can be really bad. In fact, on some Windows boxes that use DHCP, if you plug in, the box will try to send out DHCP requests saying, hey, I want an IP address, I want an IP address, I want an IP address. If it can't reach the network for 30 seconds, it'll fail, and the Windows box won't ever get an IP address. At least this is true in older versions of Windows. And frankly, it's unacceptable. You want, if you plug in a box, you want the network to come up right away. If the link flaps, you want the network to be functional again. You don't want to run spanning tree on ports that go to end hosts, because those end hosts aren't running spanning tree. Okay? So that brings us to portfast. Conf t int fast ethernet 0/1. I know this goes to a host. I'll put an interspace description on there. Host port, and then spanning tree portfast. Okay, so it gave me some warnings here. Portfast should only be configured on ports connected to a single host, connecting hubs, concentrators, switches, bridges, etc. to the interface when portfast is enabled can cause temporary bridging loops. And we saw what happens with bridging loops last week. I called them spanning tree loops. I guess bridging loop is a better word for it. You have a loop, and all the ARP requests are just circling around in your network, and kaboom, any routers attached to the net go to 100% CPU, and you have a bad day. Okay, so portfast is useful. What portfast does is when the link comes up, it'll skip spanning tree and it'll just it'll just put it directly into forwarding mode. It'll still send out BPDUs over the port, but it'll put it directly into forwarding mode. And so let's ping 10.1.1.1, and now let me unplug. So I'm unplugged, and let me replug here, and I replugged. And you can see here's the spanning tree logging, and it moved from disabled to blocking at 1 hour, 13 minutes, and 6 seconds after. Okay, so the link changed state up at 1:13:08, but at 1:13:06, while it's in the process of bringing it up, I mean, this is a slow router here, it moved the port from disabled to blocking, and it moved it immediately from blocking to forwarding. It didn't go through the listening stage, it didn't go through the learning stage, and then almost immediately I ping and it's up. Okay, so that is the benefit of portfast. And now let me debug spanning tree BPDU. Let's see if we're sending BPDUs out that port. And I'm not seeing any debug messages here at all, which is sort of strange. Show debug. Okay, for some reason my debug's not working. I'm not seeing the BPDUs I'm sending out, even though I'm certain I'm sending them. So I can't tell you immediately whether I send out BPDUs on the portfast port. I believe I do, just as an added precaution in case somebody plugs a switch in there. Okay? Now, one danger is if somebody plugs a switch in there. So what you do is spanning tree BPDU So spanning tree BPDUguard, portfast BPDUguard, what this will do is it will, if I receive a BPDU on that port, then I will disable the port. And that way, if somebody plugs, let's say it's a host port going to a desktop net or something like that, and I just want people to plug in one host, I want it to come up fast, so I'd configure portfast. But if they go and plug in a switch in their cube, they could, if they plug in a switch in their cube, they could cause an outage. In fact, I've suffered outages where people have plugged in switches in their cube and plugged them back into me, and it's caused loops. So we configure BPDUguard, and that way, if they plug in a switch, it'll send out BPDUs. If I receive the BPDU, then I will immediately block the port. In fact, let's try something. Here I am on switch 3, conf t, spanning tree, BPD, portfast, BPDUguard. And just for kicks, I'll try my debug command. Okay, my debug command is working here. No debug all. So let's go back and look at this. So here's a BPDU I receive, at 12 seconds after the minute. I receive it on VLAN 1. It's a received BPDU. It's a BPDU configuration type IEEE, which is the standard standard historic BPDU, and it has all the BPDU data in there. Presumably embedded in here is the MAC address of my root bridge. It was like 000A something or other. Yeah, 001A. Yeah, here it is. Let's show spanning tree. 001A 6C16 1200 is the root address. And here on Fast Ethernet 1, 001A 6C161200. Remember what I said about the spanning tree bridge has the spanning tree bridge has the MAC address of the bridge in the BPDU, and there it is. And then there's the priority 24577. Well, that's in decimal. What is that in hex? You know, I'm going to guess that in hex that's 6001. Let me pause for a second. Yep, using Google, I was able to immediately, I did a Google search on hex to decimal, and I can convert 24577 to hex, and it's 6001. So yeah, here in the BPDU, this is 6001 is the priority of the root bridge. So you can see how the root bridge is embedding stuff in the, you can see how the root bridge is embedding information, its own MAC address and its priority in the BPDUs, and it's sending them out every 2 seconds. Here's 16 seconds after the minute, here's 18 seconds after the minute, and I receive, at 18 seconds after the minute, I received this BPDU on Fast Ethernet 0/1, and also at 18 seconds per minute, I receive a BPDU from Fast Ethernet 0/2. And you notice the BPDU that I received from Fast Ethernet 0/2, it has the same root bridge, and that's because switch 1 is originating the BPDUs because it's the root bridge. Switch 2 does not originate BPDUs. It receives the BPDU from switch 1 and it passes it on, possibly changing some cost information and other stuff in there, but in effect, BPDUs flow from the root bridge once spanning tree is stable. Okay, so there I am, and I'm receiving BPDUs, and we were talking about bpduguard. So let's conf t spanning tree bpduguard, spanning tree portfast, bpduguard. Okay, and what this is going to do is it will, if I configure portfast on a port and I receive a BPDU, I will put the port in error disable mode. Now let's do something incorrect. Let's configure portfast on Fast Ethernet 0/1 and see what happens. Show int fast 0/1. And you can see it's up, and connected. Conf t int fast 0/1, spanning tree portfast. Oh, and look at this. Spanning tree block bpduguard. It tells me that I received a BPDU on port Fast Ethernet 0/1. bpduguard is enabled, and so it's disabling the port. bpduguard error detected on Fast Ethernet 0/1, putting Fast Ethernet 0/1 in error disable state, and then the interface goes down. Now let's show int fast 0/1, and you can see that Fast Ethernet 0/1 is down, line protocol is down, it's error disabled. Okay, so bpduguard works. Now notice that's a global command that enabled bpduguard on all ports on the switch that have portfast enabled. Okay, so let me try to fix it. Int Fast Ethernet 0/1, no spanning tree portfast. show int fast 0/1. You know, I got port fast turned off, but you know this port is still error disabled. So to re-enable it, conf t, I'm going to have to go to 0/1 and I'm going to have to do a shut, no shut. Show int fast 0/1. And then you can see that finally it's up and we're all back to normal. We disabled port fast, but we also had to bounce the port in order by shutting and no shutting it in order to remove the error disable. Okay, so that's spanning tree port fast. Port fast says skip listening and learning modes, go directly from blocking to forwarding. It's designed for use on ports that go to just general hosts or routers, but don't have any don't have any switching on it. You don't want to use it on going to switches. And then you can configure BPDUguard globally on your switch, so that way portfast BPDUguard. So if you receive a BPDU on a portfast port, it will put it in error disable mode. Once you're in error disable mode, you can fix whatever the problem is, and then you have to shut and no shut the port in order to get out of error disable mode. Now, let's say you have a large campus network, and every time somebody plugs a switch in, you disable the port, but you know, then their port is disabled forever, right? They're going to have to send in a case or a ticket or something in order to get that fixed, right? That's not good. What you want to do is you want to discourage them from plugging switches in. So they plug in a switch, you want to disable it for a while, but then you want it to automatically re-enable itself after a while once they've learned their lesson, that, you know, and it's sort of a subtle hint to them that maybe they shouldn't go and plug in switches in their cube and plug it into your infrastructure that you control. Okay, so conf t, let me error disable recovery cause, and there are many reasons for a port to go error disable. It could be a channel misconfig, it could be due to repeated link flapping, storm control. You can enable unidirectional link detection. There are lots of things you can enable to error disable a port under certain circumstances. And in fact, that's exactly what bpduguard is. It's a feature that disables a port under certain circumstances, and the circumstances if you receive a BPDU. So we got the BPDU error disable recovery cause, bpduguard interval. Actually, there's an interval command here. Interval, let's make it 15 minutes. So 15 minutes is 900 seconds. Error disable recovery interval 900, which is 15 minutes. And then error disable recovery cause bpduguard. Show run pipe include error disable. So what this means is if somebody plugs in a switch and it's a port that you have port fast on and you've got the portfast bpduguard enabled, then the port is going to go in error disable mode. Every 15 minutes, the switch is going to go and re-enable the port, and after 15 minutes, the switch is going to re-enable the port. Now, of course, if there's still a switch there and it still sends us BPDUs, then we'll error disable it again. But what this means is, you know, typical user, they plug in a switch in their cube, stuff doesn't work. They plug in a switch in their cube, you disable the port, it goes in error disable, and then, they're trying to figure out what's going on, and they get frustrated. They go to lunch. They, maybe they unplug it, and they can't even plug in their host anymore. And they sort of, before opening a case or something like that, people usually go and do something else for a while. They just sort of hope the problem goes away. And frankly, this will make the problem go away after 15 minutes. They go to lunch, they come back, and the port is as it was, and they can plug in their host, but they'll have learned their lesson not to plug switches into your infrastructure. And you won't have to get a case and manually go and figure out which port is error disabled and re-enable it, which saves you work and saves them work, because opening a case is always a pain in the neck for the user too. Okay? So portfast, bpduguard, and then we've got the error disable recovery. You can do different causes, and you can set an interval. Okay, rootguard. Let's go back to our map. What rootguard is This is our root bridge. This is our backup root bridge. Now, let me go and plug back. You know, in production, I would actually have a 2-link ether channel between these two switches. And we'll talk about how to do ether channels later. That way, and those 2 links, I would put them on different line cards if it was a large modular switch. So that way, there would be no single point of failure between these 2 switches. In those circumstances, this should always be the root bridge unless it's down, in which case this is the backup root bridge. And for these switches down here, their root port should always be on one of their 2 uplinks. On these switches, the downlinks should never be a root port. So what rootguard is, and frankly, fast Ethernet 0/1, if I was plugging into a switch to a lab or something like that, I would not want that lab to become the spanning tree root for my domain. So how do you prevent that? Well, what you do is you configure rootguard. And what rootguard is it's a feature where if you receive a BPDU from that direction which says, hey, I'm the root, then you disable the port. So let's see, let's try to configure fast Ethernet 0/3 and fast Ethernet 0/1 as rootguard ports. So conf t int fast 0/3 spanning tree guard root. And then int fast 0/1, which goes to that router. Spanning tree. I've got portfast-enabled there right now. So if I receive a BPDU at all, I'm going to disable the port. Whereas on fast Ethernet 0/3, if I receive a BPDU which says, I mean, I could receive BPDUs. There's another type of BPDU called topology change BPDUs. But if I receive a BPDU that says, hey, I want to become the root, or I receive a BPDU which has lower priorities, so I would abandon my root ship and set my root port out fast Ethernet 0/3 and believe that a switch out here was a root switch, then I would disable it. In fact, we can go and see that at work. Here I am on switch 2, and show spanning tree. Let's say that I decide that I never want fast Ethernet 0/3 to be my root bridge because I've set things up in such a way that the link between 1 and 2 will never go down, possibly by being a 2 gig ether channel on diverse ports and everything like that. So conf t int fast 0/3 spanning tree guard root. Okay, so rootguard is enabled in fast Ethernet 0/3. Show spanning tree, and I can see that my root port is out fast Ethernet 0/1. Now, just for kicks, let's go ahead and conf t int fast 0/1. Let's say we messed up and somehow this link between 1 and 2 did go down. And of course I'm going to make it go down by just configuring it shut. So it is down now. Conf t int range. Okay, so what happened is, because this link was down, fast Ethernet 0/1 used to be my root port, and eventually I decided that, hey, I lost my link to my root port, I'd better try to listen for other BPDUs, and eventually I did receive a BPDU from the root bridge 1 via my fast Ethernet 0/3, which said I should set my root port to fast Ethernet 0/3. But Because of the root guard, since I received a BPDU which would cause that port to become root, then because of the root guard, I disabled the port. And so show int fast 0/3. Line protocol on interface VLAN 1, change state to down, show spanning tree. I was expecting to find the port physically error disabled. Okay. So, I see what's happening here. For VLAN 1, fast Ethernet 0/3 is type root inconsistent. And so basically I've disabled fast Ethernet 0/3, but only for VLAN 1. So because it's disabled, my box thinks that I am the root. And let me see ping 10.1.1.2. Yeah, and I've lost network connectivity here. So even though the port is physically up, on VLAN 1, I'm not going to allow any traffic to go out fast Ethernet 0/3 because it's in root inconsistent mode because of the root guard. Ping 10.1.1.4. Let's see, VLAN 1. VLAN 1 is protocol down. So it seems weird about what root inconsistent did to me, but it definitely reacted to receiving the BPDU on the other port and show int VLAN 1. Conf t int VLAN 1 shut, no shut, show. Okay, so that's a bit different than what I expected rootguard to do, but it definitely is not allowing this switch is definitely not listening to it's definitely not listening to the BPDUs coming in on fast Ethernet 0/3. So I'm going to reread exactly what rootguard does. Conf t int fast 0/3 no spanning tree guard root, and you can see that rootguard was disabled on fast Ethernet 0/3, so immediately the box decided to unblock port fast Ethernet 0/3 on this VLAN. So yeah, that's what I think. And then ping 10.1.1.2. Still not working. Maybe spanning tree is reconverging right now. Conf t int range. The line protocol on VLAN 1 came up. Ping 10.1.1.2. And now it's pingable. Okay? So rootguard is useful. If you're connecting to a switch that's outside of your control, you don't want it to become a root for your domain, so you configure rootguard on it. And if it does try to become root in your domain, then you will protect yourself. Exactly whether that protection means disabling the port or just not listen to BPDUs, I'm not quite sure, and I'll need to reread that before the next episode and clarify. So rootguard is useful when you're connecting to switches that are outside of your control and you don't want them to become the root. Okay, what else do we want to cover today? BPDU filter. This one should be good. So BPDU filter is sometimes misunderstood. It is an incredibly dangerous command, and it's sometimes used by service providers that are providing layer 2 services to their customers. They don't want to accept any BPDUs from their customer, and so they configure BPDU filter. What BPDU filter does is it filters out BPDUs. You receive a BPDU, it deletes it. It still keeps the port running, but it deletes the BPDU. Well, what's the problem with that? The problem with that is that the whole point of spanning tree is to prevent loops. And BPDU filter is one of the quickest and easiest ways to result in a bridging loop. I called it spanning tree loop in last episode, but really a bridging loop in your network and nuke your network. And let's see if we can do it. So here I am on switch 3, and I type in ENB, which is a typo, and then the box tries to look it up on its DNS server, which is not configured, and it's going to sit there for a couple seconds. That's annoying. Okay, const t, no IP domain dash lookup. If you misspell words, often misspell commands. Now if I type ENB, nothing happens, and I'm immediately at my console back. So no IP domain dash lookup is a nice command when you're working in a lab and you don't have a DNS server, and you just want to be able to, if you mistype something, you don't want to wait for 5 seconds while it tries to do a DNS query via a broadcast. I mean, great, like that's going to work. Okay. So let's see, const t ints fast, let's see, I'm going to fast 0/1 spanning tree BPDU filter. Enable. And I don't know if that's enough to cause a loop. Int fast 0/2 spanning tree BPDU filter enable. That should be sufficient. I'm now filtering BPDUs on both of my uplinks. So switch 1 is the spanning tree route, and it's sending out BPDUs, and instead of receiving them, I'm just throwing away. Meanwhile, so switch number 1 is going to go it's going to have forwarding ports on 02 and 03. Switch number 2 is going to forward the BPDUs out fast Ethernet 0/3, and I'm also going to throw them away. So it has forwarding ports on 01 and 03. Meanwhile, my switch number 3, I'm not receiving any BPDUs because I'm filtering them, so I'm going to be forwarding on 01 and 02. So let's see what happens. Show spanning tree. This bridge is the root. Why am I the root? Because I'm not receiving any BPDUs, so I think I'm the root. And in fact, I'm sending BPDUs out both my ports, but sending out the BPDUs, I have my priority is higher, so those boxes up there, 1 and 2, are going to ignore them because they have a spanning tree with a lower priority. Show proc CPU. Let me see if my loop is in progress yet. 4% CPU. Ping 10.1.1.1. Ping 10.1.1.2. Show proc CPU. Don't see a loop yet. I wonder if I left the rootguard enabled somewhere. Let me look around for a second. Oh, I know why. Remember I shut down fast Ethernet 0/1 on switch 2? That's why I didn't have a loop, because I didn't have anything to loop because I shut down fast Ethernet 0/1 when I was doing the rootguard exercise before. Okay, show proc CPU. Ping 10.1.1.1. Show spanning tree. Actually, I should have to wait. So I'm in learning mode. My root port is fast Ethernet 0/1, but I'm still in learning mode, so I'm not forwarding traffic out yet. And now I'm forwarding show proc CPU, ping 10.1.1.1, proc CPU, ping 10.1.1.5, an IP address that does not exist. That'll result in an ARP request, which is an Ethernet broadcast. And that Ethernet broadcast will get flooded. Show proc CPU. Ah, and there we are. Yep, 88% CPU, 50% due to interrupts. What's the other rest? 30% ARP input. I've got that ARP request. So the reason that ping to 10.1.1.1 did not result in a loop, did not start forward flooding around, is because I already had an ARP entry in my router, so I did not need to generate an ARP request. So I just generated a frame that was destined for the MAC address of 10.1.1.1, and the switches all knew how to forward it there without flooding it. But as soon as I pinged 10.1.1.5, which I did not have an ARP entry for, then I generated an ARP request and broadcast that out, and that Ethernet broadcast gets forwarded out all of the forwarding ports. And as you can see, all the ports are forwarding on these boxes, because in spanning tree, it's like switch 3 does not exist, okay? So what did I do? I configured BPDU filter on the uplinks on switch 3, and guess what? In effect, I turned into a spanning tree black hole. It's still forwarding traffic, but it's not forwarding BPDUs. So the two switches are talking BPDUs on this link and saying, hey, we don't have a loop. Spanning tree just thinks that the whole topology is just switch 1 and switch 2. But switch 3 is out there and still forwarding traffic. Okay, so BPDU filter is incredibly dangerous. The only time I think it's ever used is by service providers that provide layer 2 services to customers, and unless you really know what you are doing, I suggest you never configure BPDU filter for the remainder of your natural life. Carry on back on switch 3, and let's show proc CPU. I'm at 98% CPU, show int fast 0/1, and wow, I'm getting 53,000 packets per second inbound on this interface, and I'm doing 53,000 packets per second outbound on the interface, and it's 27 megabits right now. And there's nothing generating traffic on this net. It's just it's just one router and 3 switches. Wow. Spanning tree or bridging loops are ugly. Conf t int fast 0/1, no spanning tree BPDU filter int fast 0/3, int fast 0/2 is actually what I wanted. No spanning tree BPDU filter, show spanning tree. And already, now that I'm actually receiving BPDUs, the port moved into blocking. I have a root port, which is forwarding, and I have an alternate port, which is blocking. Show proc CPU, and I have recovered from my network outage. CPU is 5%. Okay. Next thing I want to talk about is Uplink Fast. Debug spanning tree Uplink Fast. I talked about ports in, we know about root ports. That's the port that is facing, that you forward to get to the root bridge. We talked about designated ports. Each segment will have one designated port on it. So on, the root port, so on switch 2, fast Ethernet 0/1 is a root port, and you forward on that. Fast Ethernet 0/2 is a designated port. The designated port is always on the root bridge side. Fast Ethernet 0/3 on switch 1 is designated. On this segment, either Fast Ethernet 0/3 will be designated or Fast Ethernet 0/2. So one of them will be designated and one of them will be blocked. And given that the priority is lower on this switch, since it's the backup route, you would expect Fast Ethernet 0/3 to be designated and Fast Ethernet 0/2 to be blocked. and indeed that's true. Fast Ethernet 0/2 is blocked. But you notice its role is not a root port or a designated port or a blocked port. It's an alternate port. What does that mean? Well, I'm not sure what it means, but I think it has something to do with this Uplink Fast feature. What Spanning Tree Uplink Fast is designed to do is it is on access switches that are never intended to become root bridges. You generally have two uplinks. One is primary and one is blocked. One is forwarding and one is blocked. Well, if this one goes physically down, and the only other port that this switch ever received BPDUs on is this port, then why couldn't this switch immediately start forwarding on the other port? Normally it would wait, listening, learning, and then forward. You take a very long outage, right? Well, let's see what happens. So const t int fast 0/ or int range fast 0/1 to 24 logging event spanning tree. And const t, it's a global configuration command for the switch. Notice back here my spanning tree priority, my root bridge spanning tree priority is 24577. My spanning tree priority is 32769. Spanning tree uplink fast. Okay, we got some log messages here. Uplink Fast is enabled. Uplink Fast. Fast Ethernet 0/1 is uplink. Not sure. Disabled. New route. Fast Ethernet. Pre-route not set. Current state forwarding role uplink. Make forwarding. Okay. Show spanning tree. Now this is interesting. Spanning Tree Uplink Fast is designed for those access switches down in your closets. One of the things that Uplink, it doesn't want to become a transit switch. So one of the things that Uplink Fast does is it increases the priority number, which makes you very unlikely to ever become a root bridge. Now, Fast Ethernet 0/1 is the Fast Ethernet 0/1 is the root bridge, and then we have an alternate port. Let's see what happens. I'm going to physically unplug Fast Ethernet 0/1, and we'll see how fast we recover. Wow, that was fast. We're already up. What happened? Spanning Tree VLAN. No, Spanning Tree is running on a per VLAN basis. We only have VLAN 1 in this environment. Fast Ethernet 0/2 moved to forwarding immediately. And the previous root port was Fast Ethernet 0/1. Now let's see what happens when I plug Fast Ethernet 0/1 back in. And again, I'm up. So what Uplink Fast did is it remembered the previous forwarding port, Fast Ethernet 0/1, and it show spanning tree. And you can see I'm back to, Fast Ethernet 0/1 is still an alternate port, and it's still blocking. I'm sorry, that's not quite what I expected. And now it changed it, ping 10.1.1.2, and it's pingable. So Uplink Fast is really, really cool. What it does is it says, hey, I'm an access switch, I have uplinks. Under normal circumstances, one of them is the root port and the others are blocking. Well, guess what? If the root port goes physically down, don't wait for spanning tree to reconverge before activating another root port, just activate one right away. And then when you switch back, you just disable the backup root port and you re-enable the primary root port and you don't take an outage. So Uplink Fast is very, very helpful at minimizing outages on access switches. And the recommendation is to, at least before Rapid Spanning Tree, Rapid Spanning Tree's later episode, the recommendation is to the recommendation is to always have Uplink Fast enabled on all of your closet switches, but not to configure Uplink Fast on your root or backup root bridges. And in fact, the Uplink Fast switches do not want to become transit switches because that's dangerous. So what they do is they change the priority to a higher number, which means the switch is less likely to become root. Okay, long episode. Almost done. Last feature, backbone fast. What the original spanning tree works by timers. The root bridge sends out BPDUs every 2 seconds. And the maxage timer is 20 seconds. Everything's based on that. If you don't receive a BPDU from the root bridge for 20 seconds, then you do something about it. But 20 seconds is a long time. Okay? So let's say that switch 2 has this link go down, fast Ethernet 0/1. It should do something about it, right? Well, the problem is that if it the problem is what's it going to do about it? It might want to start forwarding out one of these ports down here, but Uplink Fast is not really designed to do that. This port down here, fast Ethernet 0/2 on switch 3, is in blocking mode, and switch 3 will have to wait 20 seconds. For 20 seconds of not receiving BPDUs on this port before switch 3 will start sending out BPDUs on fast Ethernet 0/2. Okay, so, and the problem is switch 3 does not know that this port up here on switch 2 went down. So what backbone fast is it's a communication protocol between Cisco switches where these backbone switches will basically say, if one of their links goes down, it basically says, hey, something changed in the backbone. Let's try to speed things up a little bit. And I don't know the technical details of how it works, but to configure backbone fast, the recommendation is if you have an all Cisco network which supports backbone fast, you configure backbone fast on all of your switches. So let's go ahead and start that. Conf T, spanning tree backbone fast. And then I will have to go to the other. Conf T, spanning tree backbone fast. Conf T, spanning tree backbone fast. And show spanning tree. Doesn't say anything about backbone fast. Show spanning tree detail. Show spanning tree detail tells us lots of cool information. You might want to look through it. Okay, so here I am on switch 2, and if this link went down fast Ethernet 0/1, then I would not receive BPDUs and I would not send them on to switch 3. And after 20 seconds, switch 3 would figure it out that it's not receiving BPDUs, and then it would transition this state from fast Ethernet 0/2 from blocking to listening to learning mode, and then to forwarding mode. Now, so that's 20 seconds for maxage, plus 15 seconds for listening, plus 15 seconds for learning. So forwarding is 50 seconds later. So I would expect to suffer an outage for 50 seconds. But now I've configured backbone fast, debug, spanning tree backbone, turn on, and so fast Ethernet 0/1 on switch 2. Let me unplug it and see how fast we recover. It's unplugged, and ping 10.1.1.2, ping 10.1.1.2, and we're down, and about 10 seconds now. 15 seconds, 20 seconds, and now I got connectivity back after about 20-25 seconds. Let me see if anything was in my logs about Backbone Fast. So I tried to enable Backbone Fast debugging, but it didn't work. Didn't give me any useful logs. But it was apparent that the reconvergence was still slow, like on the order of 20-25 seconds, but it was faster than the 50 seconds that we were expecting. Okay, what supposedly happened with Backbone Fast? Now, what happened is that these three switches are all talking Backbone Fast to each other. Show spanning tree. My counters for Backbone Fast are all 0. So I'm not convinced that this is working right, but the timing still felt faster, like it was working. So what Backbone Fast is supposed to do is these switches, when this switch sends out, realized that its root bridge went down, it's supposed to send out a root link query saying, hey, do you have a path to the root to all of its other paths? And since Backbone Fast was running on this switch, it would say, hey, I have a link to the root. You had a link to the root and you had a failure, so maybe on my link to you, I should go immediately from blocking state to listening state, and basically immediately age out the maxage, which is 20 seconds. So that theoretically should decrease the spanning tree convergence time from 50 seconds to 30 seconds, which is still not great, but it's pretty good. So that's what Backbone Fast is supposed to do. Okay, so let's finish up what we've talked about today. We talked about the importance of setting your spanning tree priorities so you know where your root bridge and your backup root bridge are. We showed an example where we had insufficient redundancy between our root bridge and our backup root bridge, and we tried to configure rootguard down on the downlinks and ended up in trouble. We configured portfast, and you should configure portfast in all your access switches that connect to end hosts. We configured a global bpduguard command, which basically says if I receive a BPDU on a portfast, on a port configured for portfast, that means somebody plugged in a switch to a host port and I should error disable it. We looked at the error disable timeouts so that we can make it so that it would automatically re-enable after 15 minutes. We looked at rootguard, which is good when you're connecting to a switch that definitely should never become the root. Like a lab switch is a great example of that. We looked at BPDU filter and how dangerous it is, and configuring it in production is really bad and can cause outages, bridging loops. We looked at Uplink Fast. Your access switches should have Uplink Fast, so that way they can rapidly fail over between their two uplinks, and that's very helpful. It felt like immediate convergence. And then Backbone Fast. If your network is an entirely Cisco network, you can configure Backbone Fast on all of your switches, and they will tell each other about indirect link failures. Uplink Fast helps with direct link failures. Backbone Fast helps with indirect link failures. Of course, in this day and age, we all go and configure rapid spanning tree, but that's a later episode. Okay? That concludes today's long spanning tree episode. In our next episode, we're going to talk about 802.1q trunks, and we're going to, and after that, we'll get into the VLAN trunking protocol.